Hello students, so today we are going to learn a concept which will help you to solve problem related to pulley and constraint. Like you can see this question. In this question, we have to find acceleration of all three blocks. If we name it block 1, let me select white color, block 1, block 2, block 3. We can assume masses are also m1, its mass is m2 and its mass is m3. So now we want acceleration of all three blocks, means a1, a2 and a3. So when we'll make free body diagram or force body diagram of all these three blocks, like block 1, block 2, block 3, you will get three equations. Like for block 1, if we make FBD, downward M1G and upward tension. If tension is T in this, so here also tension will be T, here also tension will be T, here also tension will be T. So we can clearly see here upward tension is T, downward M1G, and we assume that this block is going down with acceleration A1. So we can clearly write M1G minus T is equal to M1A. So downward acceleration A1, so net downward force is equal to M1G minus T is equal to M1A. So similarly, we can write equation for this one too. This one equation will become, we assume that this second block is also going down. We can assume anything. We are independent for our assumption. So we will write M2G minus, here total tension upward is 2T. So we'll write 2T is equal to M2A2. This one also A1. And we assume that third block is also going down with acceleration A3. See, all three acceleration will not be equal. Don't assume that this block, this block, this block, all three block is going down with acceleration A. No, all three will move with different acceleration. Even if they are moving with same acceleration, we have to assume their acceleration different. Direction we can choose anything, but magnitude we have to assume different. Like this is going down with A1, this is going down with A2, this is going down with A3. Similarly, for third block, we can write equation as M3 G minus T is equal to M3 A3. Now here you can see one equation, two equation, three equation, but number of variable A1, A2, A3 and tension. So here we have three equation and four variable, and we all know that if we want to solve system of linear equation, number of variable should be at least equal to number of equation. I mean, if number of variable is less, fine, but number of equations should not be less than number of variable. Here we have four variable and three equation, so this cannot be solved. So we have to generate one more equation, and then we will have four equation and four variable, and we will be able to solve this problem. So today we are going to learn how to generate that fourth equation. One way you all know, using constraint relation, but often student find constraint relation little tough, like particularly for NEET students, they find little tough. So we are going to study replacement of constraint relation. No need to study constraint relation to solve these types of simple problems. So let's start now. So here we have the same picture here. Here assume that this block, this block, this block, all three blocks go down by a distance x. Means now this block reaches here, and distance by which it moved is x1. This block also go down, and assume it is a block, and distance by which it moved down is x2, and this block also go down, and distance by which this move down is x3. Now if we make force body diagram for all three blocks, see, first block, upward force acting was tension T. Here tension is T. Here also we all know tension always act away from any object, so tension will always be away from the object, all three blocks, and downward force will be M1G. Similarly for second block, downward force will be M2G and upward force will be 2 into T. Here both tension are acting upward on the second block. So total tension acting on the second block is 2T. Similarly, for the third block, downward force will be M3G and upward force will be T. This move down by a distance x1, this move down by a distance x2, this move down by a distance x3. Now we have to use work energy theorem or work energy power concept. Like tell me, two forces are acting. Let's take first block 1. Two forces are acting on block 1, tension and M1G. If block is moving down, so work done by M1G will be positive and work done by tension will be negative, because tension is upward and block is going downward. Similarly, in for block second, work done by tension negative, work done by M2G positive. Similarly, for third block, work done by M3G positive and work done by tension negative. See, I hope you are clear with internal and external force. There is no specified internal force or specified external force. I mean, we cannot say that this force is universally internal force. It depends on our system. If same force is behaving like internal force for some system, same force will behave like external force for some system. Like assume that in our body we are applying force from my one hand on my other hand. If we are studying the whole of my body, what will be that force? That force will be internal force. But if we study only one of my hand, let's suppose left hand, so force applied by right hand on my left hand will not be internal force, but it will be external force. So force is internal or external, it depends on which system we are studying. If the whole system we are studying, some force will become internal, same internal force will become external force if we are only studying a part of the system. A very basic example we will take. Suppose that here one block and second block, two block we have. This have nothing to do with this question. I'm just explaining internal and external force. So if this block will apply some force on this, which will be normal, and this block will also apply normal force on each other. If we only study second block, then this normal force will become external force. When it will be pushed, both will apply normal on each other. But if we study the whole system together, now the same normal will behave like internal force. So I hope you are clear with internal force and external force. In this case, if we study this block, this block, this block, any of them independently, like here, if we ask work done by tension, so it will be negative. Work done by tension, negative. Work done by tension, negative. One more thing you have to remember, work done by tension on all three block is negative, but only if our all three assumptions are correct. We have assumed that all three blocks are moving down. So if really all three blocks are moving down, only then work done by tension will be negative. If our assumption is correct, if our assumption is wrong, it will become positive. So remember this, work done by tension is negative only if our assumption is correct. Okay, so now what I told you, work done by tension on this block, only this block is negative. This block is also negative. This block is also negative, or it may be positive to our if our assumption is wrong. We will check that at the end. But one thing we can clearly say, work done by tension on block 1 is not 0. Work done by tension on block 2 is not 0. Work done by tension on block 3 is not 0. Why? Because when we are studying only one block, this tension is not internal force, but this is external force. When we are studying second block, again tension is external force for second block. Again tension is external force for third block. But if we study the whole system together, yeah, I am saying that I want to study the whole system together. Now, if we study whole system together, whole system together, whole system together. Now, all these forces are internal force. See, gravitational force is not internal force because gravitational force is applied from outside. But for the whole system, tension is internal force because this tension is generated within the system on this string. This tension is not generated from outside. This tension is generated within the system. So if we study the whole system, tension is a work done by tension is going to be 0, but not for individual. when we are studying for whole system, we cannot say work done by tensor on block 1. No, whenever we are saying for the whole system, work done will be calculated for whole system. Now we will add individual work done by all three and add up to 0. So here work done by tension on block 1 1. So work done on block 1 will be how much? See, tension is upward, displacement is downward. Tension is T, displacement is x1. So we can write T x1 but with negative sign. Similarly, work done by tension on second block. What will be work done by tension on second block? Tension 2T is upward and displacement is downward x2. So we can write minus 2T x2. I hope you all are clear why we are writing negative, because both are in opposite direction. And similarly, W3 will become minus T into x3. These all three work done are for individual, but some of these will be 0. See here, when we are writing W1, W2, W3, this is work done by tension on block 1. We are only studying block 1. So this is not 0, not 0. This is minus Tx1. When we are studying work done by tension on second block, this is minus 2x2, minus 2Tx2. It is not 0 because we are only studying second block. Here tension is external force. When we are calculating work done by tension on third block, W3 is equal to minus Tx3. Again it is not 0. Why? Because when we are only studying work done on third block, tension will become external force. But if we say that, what will be W1 plus W2 plus W3? You can clearly see when we add all three, W1, W2, W3, now we are calculating work done by tension for the whole system, because in this system only three blocks are moving. Work done is only calculated for moving particle. Here we only have three moving particle: block 1, block 2, block 3. So if we add all three work done, it will be work done by tension for the whole system. So this will be work done by tension on the whole system. So when we add all three, because only three blocks are moving, so when we'll add all three work done, it will become work done by tension on the whole system. And since for the whole system tension is an internal force, again for individual block tension was external force, so work done by tension on an individual block was not 0. But for the whole system, tension is an internal force because tension is generating within the system. So work done by tension, sum of work done by tension for all three blocks will be 0. Again, tension is external force for individual block, so work done by tension was non-zero, this all three. But if we consider whole system, now tension became internal force. So total work done by tension for the whole system is going to be 0. Means W1 plus W2 plus W3 is going to be 0. So now we will put W1 plus W2 plus W3 is equal to 0. Now remember the value. What was W1, W2, W3? Minus Tx1 minus 2Tx2 minus Tx3. So minus Tx1 minus 2Tx2 minus Tx3 is equal to 0. Here clearly you can take T common and minus also common. So we will get x1 plus 2x2 plus x3 is equal to 0, is equal to 0. So now see, this is a relation between displacement of all three blocks. Like if block 1 displaces downside by x1, block 2 displaces downside by x2, and block 3 displaces downside by x3, then x1 plus 2x2 plus x3 will be 0. Here we can clearly see if all three are displacing downward, means x1, x2, x3 all are positive, then we cannot get 0. Sum of all three positive number cannot be 0. Means at least one block or maybe two block of these three will displace upward. So if we are taking downward displacement and block is displacing upward, so displacement will become positive. So at least one or two of these three will be 0 at any cost. Clear? So this is the relation between displacement of all three blocks. Now if we differentiate it on taking derivative with respect to time. We all know if displacement is differentiated with respect to time, we'll get velocity. So it will become v1 plus 2v2 plus v3 is equal to 0. So at any time, if all three blocks are, we are assuming that all three blocks are moving down with speed v1, v2, v3, then v1 plus 2v2 plus v3 is equal to 0. Again, we can see if all three blocks are going down, then v1, v2, v3 all will be positive, and some of these three cannot be 0. Means at least one block or even two blocks have to go upside. Taking one more time derivative, taking one more time derivative, we will get a1 plus 2a2 plus a3 is equal to 0. So this is the equation we wanted in the beginning. Remember, here we have three equations, but we need one more equation, the equation which relate acceleration of all three blocks. Now we got that equation, a1 plus 2a2 plus a3. So now we can write fourth equation, a1 plus 2a2 plus a3 is equal to 0. Now we have four equations, four variables. Very easily we can solve all these four equations and find the value of tension a1, a2 and a3. I hope you understand this. One more case I'll take, and I'll write general case. Here we have put the value of tension like T minus 2T minus T. I mean, here we have put the value of tension. So when we are we want to write the general formula for this, so there we will not put the value. So this equation will become, suppose that there are some system where n blocks are moving, so we can write work done on first plus work done on second plus work done on third plus dot dot dot. We are writing general formula will be 0. Work done will be tension on first block into displacement of first block plus tension on second block plus into displacement of second block plus tension on third block, displacement in third block. And if tension and displacement is opposite direction, it will be negative. If same direction, it will be positive. And plus tension on, sorry, just 1 second, plus tension on nth block, displacement of nth block is equal to 0. Or we can write, if we differentiate it, we will get T1 V1 plus, because tension is constant, so it will remain same, plus T2 V2 plus T3 V3 plus Tn Vn is equal to 0. Again, if particle is moving along the direction of tension, Tn into Vn will be positive. If both are in opposite direction, it will be negative. Or if we differentiate one more time, we will get T1 A1 plus T2 A2 plus T3 A3 plus Tn An is equal to 0. So in short, we can write sigma T dot A. Actually, this is not only T1 A1, we can write it T2 dot A2, because work done is, we all know work done is dot product. So here all we should write T2 dot X2, because work done is a dot product. Here we are writing without dot, because we know that both are either in opposite direction or same direction. So if they are in opposite direction, we have to add negative sign, or if same direction, positive sign. So sigma T dot A is equal to 0. This is the equation which we were searching for. Now in any question, we will very easily develop our third equation. T dot A, tension and acceleration. Make free body diagram, or just assume, without even making free body diagram, just assume the acceleration, in which direction the block or any particle is moving, and find the tension. If you assume the acceleration in direction of tension, then T dot A will be positive. In opposite direction, T dot A will be negative. And one more thing, this theory will only be valid if tension and acceleration are either parallel or anti-parallel. Like suppose that in some of the case, question is given like this, like this direction tension and particle is accelerating in this direction. Here both are neither parallel nor anti-parallel, means angle is neither 0 degree nor 180 degree. So in this case, this concept will not be valid. This concept will not be valid. So always use only when T and A or T and V or T and X displacement are parallel or anti-parallel. I hope you understand. This will help you to solve problem. While if you are really finding little constraint a little tough, then this will help you a lot. Thank you.